Good evening, friends. Now I want to explain about the hydrogen bonding. This is one of the important concept in the organic and also inorganic chemistry. This must you have to remember this hydrogen bonding. Now I want to explain about hydrogen bonding. What is a hydrogen bonding? What is the bond energy exhibit series? Just I will explain in which molecule will show the hydrogen bonding. That I will explain. The general hydrogen bonding forms energy series van der Waals forces of attraction. Van der Waals force is greater than hydrogen bonding in between covalent bond. This already I discussed. Covalent bond approximately energy 200 kilojoule per mole they will form. Next, this is nearly 80 kilojoule per mole. 80 kilojoule per mole. 8 to 42 kilojoule. 8 to 42 kilojoule per mole. This is when will form van der Waals bond. Van der Waals force of attraction 8 less than 8 kilojoule per mole. This is the in between van der Waals forces and van der Waals bond and covalent bond in between exists hydrogen bonding. This energy sequence also you have to remember. Next I will explain when it will form hydrogen bonding, how it will form. If you take, for example, if you take A, H, next molecule B. Due to this more electronegative attract the bond pair of electrons towards itself, it will form partial negative charge. Here we will form partial positive charge. This is fluorine, oxygen, nitrogen. This electronegativity 4, 3.53. This is having more electronegativity. This will show having more electronegativity nature. Then only it will form the hydrogen bonding. This is having deficient electrons. It will form delta plus. This is B atom having lone pair. This will partially donated to this electron deficient hydrogen atom. This bond is called as a hydrogen bond. This is also having more fluorine, oxygen and nitrogen molecule will form. But in case of it, this is inorganic. In case of organic, chlorine, here also chlorine will exhibit the hydrogen bonding. This energy approximately 8 to 42 kilojoule per mole depends upon the these two atoms. This bond energy will show. This is the covalent bond. This is 200 kilojoule per mole. Then only these atoms, fluorine, oxygen, nitrogen. Here also fluorine, oxygen, nitrogen. Then only it will show the hydrogen bonding. Other than this, it will not show the hydrogen bonding. When it will form AH, this is covalent bond, this is hydrogen bonding. This is more electronegative, attract the lone pair of shared pair of electron towards itself. Then it will form delta minus charge. Here delta plus, electron deficient. The other atom is electronegative. It will donate the electron to deficient this hydrogen delta plus atom. Then it will form the hydrogen bonding. This bond is called as a hydrogen bonding. This energy approximately 8 to 42 kilojoule per mole. This is the covalent bond. This energy is 200 kilojoule per mole. Then only it will exhibit the hydrogen bonding. These points we have to remember. Very very important when it will form the hydrogen bonding. That is very very important. Clearly I told you. Next, the bond strength. Next, one by one I will discuss. These points you have to remember. Next, if Next I will discuss A H. This this bond energy is X, this bond energy is Y. Bond energy of A is X, bond energy of B is equal to Y. This is X is always greater than Y maximum times, because this is a covalent bond, this is a hydrogen bond. So bond energy of A is greater than bond energy of B. Next, bond energy of A approximately equal to the bond energy of B. Third one, bond energy of A is greater than bond energy of B. This is possible or not? This is existed in this. If you take in case of any molecule, you can. But this is also shown in case of HF2 minus, because this fluorine, hydrogen, this Fm highly electronegative. This is exception case. This bond energy equal to this delta plus and delta minus. This is strongly electronegative nature. That's why they will form the strong hydrogen bonding with electron deficient delta plus hydrogen atom. That's why the bond energy of A approximately equal to this, bond energy of B approximately equal to 200 kilojoule per mole. This is one of the exception. This is also exhibit, but this never happened. This never happened in this case. This is not possible. Only these two conditions will follow. This is also only exception. Most of the cases, 99% this will show. Only one of the exception, only they need to show the bond energy of A is equal to bond energy of B. Next, I will give you one of the example. In this case, which one is having strong bond. If you take OH, O, first case, second case OH, nitrogen, third one NH, nitrogen, fourth nitrogen H, oxygen. Which is having the strongest bond? Strong hydrogen bond. Strong hydrogen bond. First, which one is having? First case is A, H, B. This the strength of bond is directly proportional to electronegativity of A. This means highest electronegativity. Which one? Compared to nitrogen and oxygen. Oxygen. These two have to consider. These two can be eliminated. Depends upon electron strength of the bond directly proportional to electronegativity of A. Because more electronegative, more will be the electron, more positive charge will be developed. Next we have to discuss. Next, hydrogen bond strength is inversely proportional to electronegativity of B. Why? Because this is more electronegative, more electron deficient. If in case of this is more electronegative, means this is more withdrawing. If it is less electronegative, then only it will donate the electron towards itself. In case the electronegativity is less electronegative, then only it will return. If it is more electronegative, what will happen? It will pull the electrons from this hydrogen. That's why the electronegativity of B is lesser one will form this strong hydrogen bond. This is highest electronegative, this is less electronegative. That's why this will show the strongest hydrogen bond in this case. Strength of the bond directly proportional to electronegativity of A. Strength of the hydrogen bonding is inversely proportional to electronegativity of B. These two conditions will satisfy this second option. That's why second one is the more electronegative, more suitable option, stronger one. This you have to remember. Next, we have to discuss some of the types of hydrogen bonding. This types of hydrogen bonding. There are two types of exist. One is intermolecular hydrogen bonding. Intermolecular hydrogen bonding. Second one is intramolecular hydrogen bonding. These two concepts are hard. Inter means two different molecules. Between two molecules, either the same or maybe different. This intermolecular hydrogen bonding is between two molecules, either same or differ, maybe differ. Intra means within the molecule. Within the molecule, they exhibit the hydrogen bonding. These two you have to remember. In case of, if you take different HF, like this will show the HF. This will show the like this, the hydrogen bonding we can consider. Then write example. Take like this, HF, HF, and also HF, and also HF. Between fluorine and hydrogen, between fluorine and hydrogen, between fluorine and hydrogen. Like this, they will show the hydrogen bonding here 120 degrees, like this. HF. If you take in case of boric acid also, we will show H3BO3. If you take in case of H3BO3, two different. This is due to this hydrogen and oxygen. We will show the hydrogen bonding. This is dimerization. But in case of acetic acid, in case of carboxylic acid also. Carboxylic acid, this is exist in the dimerization. If you want to calculate the weight of the dimer, this is will get 60 dimer, not 30. Like that, this is dimerization, exist in the dimerization form. This is also boric acid also will show the dimerization. Then we will exhibit the hydrogen bonding. 1990, I think. If you take in case of CH through C double bond O, what is the molecular weight? Carbon 12, 24 plus 2 oxygen 32 plus 3, 4. This one 24, 4, 10, 60. Each molecule 60. But you have to calculate the molecular weight of this one. If it exists in the dimeric form, also add one more. 120 we will get, not 60. This is due to the hydrogen bonding only. Next we have to discuss about the in case of why ice floats on ice floats on water. Why ice floats on water? Why? Because in case of what ice, case due to hydrogen and oxygen and hydrogen. This is the like, this is the like this. This is the cage structure. Hole. They will form the hole. Due to this cage-like structure exists between the molecule in case of ice, what will form due to the hole, the density of ice is zero point 0.9 gram per centimeter cube. But in case of water, water density is 1 gram per centimeter cube. Due to this cage-like structure exists in the case of ice, the density between these four water molecules, it will form cage-like structure. In between them, there is a formation of hole. Due to this hole, void or hole, the density will decreases. Density less. That's why this ice is floats on the water. When it will come, if you take for example, if you take water, what will happen? Ice is exists in the at 0 degrees centigrade. Feeds, it will form water at 0 degrees centigrade. Further it will heat to 4 degrees centigrade. It will reach maximum density. Then after will heating, density will be decreased. Volume density will be decreases. Means they will expand, volume increases. That's why the density will be decreases. First, ice at 0 degrees centigrade, it will form the tube-like structure, cage-like structure. They will form the void hole. Due to this void, the density will decreases. Further, on heating up to 0 degrees centigrade, the ice converted into water. Further heating, it will reach maximum density at 4 degrees. Then further heating, the expand the water molecule evaporated, then it forms, density will decreases. This due to this cage-like structure, the ice density is less. That's why it floats on the water. This is one of the important concepts you have to remember. Next, how many hydrogen bonding will form water? If you take this one, this is OH. This will also form another water hydrogen. Next, this will also form. This is also formed. This is also formed. 1, 2, 3, 4. 4 hydrogen bond. Each water molecule will form 4 hydrogen bond molecules. This is 1, this is 2, 3, and 4. One water molecule is surrounded by 4 water molecules. They will form the hydrogen bonding. Tetrahedral nature, tetrahedral structure. This is you have to remember. Next, we discuss about the orthonitrophenol. We take phenol. This is the ortho position. This is the meta position. This is the para position. If you take orthonitrophenol, this is the structure. This will form the hydrogen bonding. But in case of paranitrophenol, what will happen? Paranitrophenol. If you take this is the paranitrophenol. This is also formed the hydrogen bonding. This is called as a intramolecule. Within the molecule, it will form the hydrogen bonding. This is intramolecular hydrogen bonding. This is two different molecules. Intermolecular hydrogen bonding. This is having more boiling point. This is having orthonitrophenol is less boiling point compared to para-nitrophenol. Orthonitrophenol is less boiling point. This is having the highest boiling point because due to dimerization, due to two different molecules, molecular weight is more, that's why boiling point will be more. This is para-nitrophenol, this is orthonitrophenol. Due to hydrogen bonding, these can be separated, orthonitrophenol, para-nitrophenol by fractional distillation due to different boiling points. This you have to remember. This is about the hydrogen bonding. Thank you.